So in number 36, we have two long parallel non-conducting sheets with identical distribution of positive charge, with surface charge density of 1.77 times 10 to the minus 22nd, or coulombs per meter squared. In unit vector notation, what's the electric field that points above, between, and below them? Now, a couple quick things on these. These are large non-conducting sheets which have a charge density of sigma. Hopefully, we've covered the point already that for large sheets, the electric field around them is simply given by sigma over 2 epsilon naught. So in this case, what do we have? Well, the top sheet's producing a field that points both up and down. Actually, there's a whole bunch of field lines, but I'm just drawing a single set. Up and down that stretch off to infinity. And the bottom plate, very, very similar. Now, there's one quick thing you should notice. In between these plates, this field is pointing downward, this field is pointing upward. And so what happens in this case? Well, they're equal in magnitude, opposite direction. The fields are going to cancel. Whereas on the top and bottom, the fields are in the same direction. So at the top, it's just the field due to one of the plates, sigma over 2 epsilon naught, but times 2. Why? Because the fact that we have two plates. And if you plug in the numbers then, the 2's cancel, so it just becomes sigma over epsilon naught. We get that the field on top of the plate is given by this magnitude, and it's pointing in the positive j direction. What's the field between the sheets? It's just 0 because they cancel out. And below, by the same logic, you end up with this, except now it's negative that value because it's pointing in the negative y direction or negative j hat direction. Hopefully this helps.